everyone, Aaron Wolf from ENKI here. This video is an introduction to a new video series that we will be releasing called Building MELTS 2.0, a devlog. This will be a developer log that sort of shows my development process, both scientific, statistical, and computer programming, for building the newest version of the MELTS model, which we are calling for now MELTS 2.0. MELTS 2.0 is targeted at expanding the thermodynamic capabilities of the model, as well as building it on top of modern statistical approaches, namely the Bayesian statistical approach. You may be asking yourself, well, what am I going to get from the new version of MELTS? And the things you're going to get from the new version of MELTS fall into roughly three categories. Firstly, confidence and accuracy. By using the new Bayesian statistical flexible modeling approach, we're going to be able to apply additional constraints from the same data set, meaning that we'll sort of extract more power from a fixed amount of data, thereby increasing the accuracy. But perhaps even more excitingly, and honestly, I think this is the thing I am most excited about for the new model, we are going to be able to predict confidence bounds on any prediction that the model makes. So the standard MELTS model, and for that matter, almost any of the existing thermodynamic models out in the literature, take a maximum likelihood approach where they fit a model, they calibrate the parameter values, and then you can ask the model, what happens in this case? What happens in that case? And it'll give you one answer. Using Bayesian statistics, you do not simply get the best fit, but you get the entire family of models all consistent with the calibration data. And so you will be able to ask the model for any particular prediction you want to make, what is the range or probability distribution of values that the model predicts? So the model itself will indicate its own confidence for different applications. This is going to be totally amazing for scientific usage and will vastly speed up how long it will take people to learn what MELTS is good at, what it's not good at, and where it needs more training. So that brings us to point number 2, experimental planning. This is a feature that I know is in really high demand with the experimentalist community. When you're running experiments, it takes time, money, and resources, and you only have a fixed amount of those things. And so you have to decide how to allocate those resources to get the maximum bang for buck, or the maximum output for those efforts. One of the nice things about the Bayesian statistical approach is there is a thing called optimal experimental design. And that sort of uses the entire family of models that are consistent with the data to figure out what regions of space, think of it temperature, pressure, composition space, where the model is most uncertain, and then guides you to performing new experiments in those regions because you can collapse uncertainties in the model the fastest with the fewest number of experiments. And finally, the third area where MELTS 2.0 will shine is in upgrades and tunability. The original MELTS model was built using a fairly lengthy calibration process that meant that adding new data and updating the model was extremely time consuming. And it meant that new versions of MELTS came out with large gaps of time in between. It took years of effort to do. Over the course of this devlog, you'll have a front row seat to the development of a calibration tool set for ENKI and for Thermo Engine. And so we will be dramatically shortening that calibration time and the expertise required to perform new calibrations. Our goal is to make this a model that is easily updated with new data, with relatively little expertise needed and only a modest amount of effort. Think weeks, months, not years, decades. Additionally, we'll be able to tune the model. So imagine that when you calibrate against all the data, you'll get sort of an overall model that does a really good job everywhere we have data and can thermodynamically extrapolate to some extent beyond that data range. But there are many cases where you have an application in mind that's only a certain small subset of the data, a certain region of pressure temperature space, or a certain type of composition space, like say highly evolved silica-rich melts. In that case, you should be able to focus or tune the model to do a really good job where you intend to apply it, at the cost of only modestly decreasing the accuracy everywhere else where you do not intend to apply the model. So you could come up with tuned subsets of the model specifically for your personal application. What do you want to simulate? So I think together, both upgrading the model with new data, with this new toolkit, as well as focusing and tuning the model for your intended application are really going to bring a lot of value to the community of users. And overall, this also represents a sort of experiment in community building and community outreach. At ENKI, we are growing our user community, and we're also trying to educate you into how our development process works, make sure that we're developing the things that you want to use, and make sure you know how to best maximally leverage the tools that we are building. And so we need your feedback. We hope that you find this Building MELTS 2.0 devlog series useful, and please do give us feedback in all the usual ways. You know how to do it. I'm really excited to see where this goes. You'll get to see up close and personal the struggles involved with this scientific software development, as well as the successes. And I look forward to seeing you there. Okay, bye-bye.